Hi everyone, you are welcome to POSTUTME once again, and in today's video lesson I'll be showing you guys how to solve questions under equations of uniformly accelerated motion. And mind you, this is a revision class, so I will be a bit fast and straight to point. So let's get started. Now, for equations of a uniformly accelerated motions, these are the top 4 formulas you should know. Okay, let's get started. These are the top 4 formulas, where V is the final velocity, U is the initial velocity, A is the acceleration, T is the what time, X distance, and the what is time. Okay, now what are the 4 formulas of equation of a uniformly accelerated motion? The first one is V equals U plus or minus. Now mind you, in a calculation you can't make use of the two signs. It's either you are using plus or you are using minus. So the question, the big question now is, where do you know when to use plus and where do you use what? Minus. Now if you hear something like accelerated, okay, or you hear start from rest, whenever you hear any of these two, you are using plus. Are we good? Yes. Now when you hear something like decelerate, okay, or you hear retard, or you hear come or brought to rest, okay, anyone you hear, you are going to be using minus. Or if it's accelerate or start from rest, you are going to be using what? Plus. Guys, are we good? So these are the sign notations. When am I going to use plus? If you hear a body accelerate or a body start from rest, you are going to be using plus. But if you hear a body, the body then descend, or the body then decelerates or retard to rest, or come to rest, or is brought to rest, you are going to be using what? Minus. Guys, that is how simple it is. Then what else is the second formula? X is equals initial velocity times time plus or minus, which is determined by these two, 1 over 2 at and squared. Guys, this is the second formula. Then what is the third formula? V squared, that is the final velocity squared, is equal to the initial velocity squared plus or minus as determined by this 2ax. And an extra formula for uniformly accelerated motion is that x is equals 1 over 2 in bracket u plus v times time. Guys, these are the 4 formulas you should know under a uniformly accelerated motion. You will hear it in the question. They said a body accelerated from rest or is uniformly accelerated. Uniformly accelerated. I hope you get. So you just like, oh, this is what they are talking about. So you have to pick the right formula correctly. Now moving on. Sometimes the motion might be under gravity, whereby the body is either thrown up or is dropping, okay, or is falling. It's either thrown upward, vertically upward, or it's either falling, or you say dropping. Now, if you observe, it's either going up or what? Coming down. Now, observe these formulas. V equals U plus or minus gt. We all know V is final velocity, U is what? Initial velocity, G is gravity, which is what? 10. Or X indicated in the equation as what? 9.8. If it's not indicated in the equation as that, always stick to what? G equals 10. Then T is what? Time. I hope we are good on that. Now observe. When do we use plus and when do we use minus? Because if you observe this is not horizontal or linear motion. This is vertical motion. When do we use plus and when do we stick to minus? Now if the body is going upward, okay, against gravity, you use minus. But if it's falling, dropping, or coming downward in the direction of gravity, because gravity acts downward, you will stick to what? Plus. So let me just give you the trick and the shortcut. If the body is, okay, let's say going upward, if the body is going upward, you use minus. Okay? They can also replace this one and say a body is thrown upward, it's still going to be minus. So, okay, the other one is if the body is falling, okay, or you say coming downward. In this case, we are going to be using what? Plus. Guys, another way they can represent this scenario, they'll say the body is dropping. I hope that is clear. It's still going to be what? Plus. So the next formula is height, because we are moving vertically. So we don't say x. X is for distance. Height is for vertical motion, is it not? Height is equal to initial velocity times time plus or minus as determined by these two. Half gravity times time raised to power what? T. Squared, I mean. So guys, the last formula under this is the velocity squared, that is the final velocity squared, is equal to the initial velocity squared plus minus 2g8. We all know their notations and what they stand for. So guys, the next one is the set of formula for what? Rectilinear motion, instantaneous motion, and nth time motion. Okay, it's called uniformly accelerated motion because there are different types of motion the body can undergo under uniform acceleration. So for rectilinear motion, what will be given is something like this. You see something like, okay, let's say 5 bracket 5,15, let's say 20,60. Guys, this is what they'll be giving us. They'll say this is the initial, okay, while this is the what? The final. Now mind you, all these are coordinates. This is one coordinate and this is another coordinate. Now, how do you decode this? You use the word CV. CV. Don't worry, I will teach you guys better when we start taking questions. But just check, because this is the initial coordinate, they'll be carrying 1, 1. Because it's the final coordinate, they'll be carrying 2, 2. So now we know our V1 as 15, our T1 as 5, our V2 as 60, our T2 as what? 20. When we get to questions, we will definitely treat this in detail. So we progress, guys, without wasting time. For instantaneous motion, this is motion at an instant of time, or an instant in time, at a point in time. It's a very fast type of motion. So how do you now get the velocity of a body that is constantly changing its motion? Like let's say a rocket moving, its velocity is changing, is it not? A space shuttle flying, its velocity is changing at every moment or point in time. To calculate the instantaneous motion, let's say the instantaneous velocity or the instantaneous acceleration, these are the formula you use, and you make use of the word, the law of differentiation. That's why you are seeing dx over dt, dv over dt. Where the dx is the differentiation of the x function, which is the what? The function they will give you for distance. X is distance, is it not? Where your v, this dv over dt is the differentiation of the what? Velocity function. I will be showing you guys how to differentiate, but here is the basic rule for differentiation. They will say y is equals to, let's say, x raised to power a. How do you differentiate this? The answer is dy over dx, because you are differentiating y with respect to x. Okay? It will now be equals to, first thing first, what is the power? It is coming to the front. A, are you seeing that? What is the number? X. What is the power again? A. Minus 1. Are you seeing that? So that is basically done. Another form of it, this another form we can also differentiate in. You can be giving x is equals to, let's say, ax to the power n. This is standard form. Okay? How do you now differentiate this? Dy with respect to x, because x is the guy carrying the power. Observe that. Do you see that? So how do you now differentiate this? The same thing. What is the power times what is in front of x? So it will be a times n, the power, dot x, which is the number carrying the power, raised to power n minus 1. Are you seeing that? So that is how to differentiate. We will do that in practical questions so you understand better. But just note that at the back of your mind. So guys, what else? For nth type of motion, nth time motion, okay? How do you find it? For example, they'll say a body accelerates to an acceleration of this. Calculate the acceleration at the 3rd second, or at the 4th second, or the 5th second. You are saying th, 4th, th, like that. Is it not? 1st, 2nd, 3rd, 4th, 5th, 6th, like that. So when you ask such question, calculate the acceleration at the 3rd, at the 4th second, at the 6th second. How do you not get the acceleration? You don't make use of this formula, you won't get it. You don't make use of this, you won't get it. Neither this or this, you won't get it. Since this is the scenario, you make use of the formula s nth, which is depending on what the time they said. They say 3rd second, here will be s subscript 3. If they said 4th second, here will be x subscript 4. Is that clear? It will be equals to 1 over 2 times the acceleration they will always give you. They must give you the acceleration. In brackets, observe what I did. I said Tn, and in the other one I said Tn subscript minus 1. That is T subscript n minus 1. T subscript n, T subscript n minus 1. If they said 3rd second, calculate the acceleration at the what? The distance covered at the 3rd seconds, I mean. Calculate the distance covered, which is s, at the 3rd seconds. Normally we know our acceleration, is it not? Because they said 3rd seconds, you will put 3 here. What is the number behind or before 3? Is it not 2? So it will be 3 square minus 2 square. They say at the 4th second, calculate the distance covered at the 4th second. The Tn you are talking about here is the number 4, is it not? So it will be 4 raised to power 2. Then the number before 4 is what? 3. So it will be 3 raised to power 2. So 4 square minus 3 square. Like I said, we treat practical question and you see how these things are done. So guys, looking at all these things, these are the formulas you need to know in total under what? Equations of uniformly accelerated motion. You will need each of every of these formula for your questions, whether you are taking JAMB, POSTUTME, or normal school physics questions. You will need all these formulas at the back of your mind in order for you to be good in physics. So now we have all these formulas. What I will do for us is I will give you 1 or 2 questions and show you how they are solved. Thereafter, I will drop an assignment for you guys. And do it to solve it, and also do it to drop it in the comment section so I can tell you if you are correct and also provide correction if need be. So let's take the practice questions now. Alright, here is the questions we are asked to solve under equation of uniformly accelerated motion. So we'll read it together and then we'll start solving. Solution. They said in question 1, they said the velocity v of a space shuttle in a time t is giving us, let's see the function for the velocity, which is v equals 3t raised to power 3 plus 2t raised to power 2 plus 5t plus 12. Guys, this is what we have. How do we now find what? Instantaneous acceleration. Am I when they say find instantaneous velocity, or let's say instantaneous acceleration, they must give you a value for the time. In this case, they say we should take t as what? 2. So when we have differentiated this velocity function to become the acceleration function, we then impute t as what? 2. Then we can get the acceleration value. Is it not? So just what I'm talking about. Now remind you, when you differentiate the distance function, you will get velocity. But when you differentiate the velocity function, you will now get what? Acceleration. So let's see how we can now differentiate velocity function. Now, assume you are differentiating v and it become a. Like I explained there, that was when I was doing the formula side. I said, how do you differentiate this? 3t raised to power 3. 3t raised to power 3. It will be the power times what is in front. So I will have 3 times 3 c, because t is one carrying the power, raised to power 3, then minus what? Minus what? 1. This is for just this. Are we good? Plus, then again, the number in front times the power. Then what is the guy here? C, is it not? Then what is its power? 2. Minus what? Minus 1. Plus, same thing here. Now, whenever you see 5t, there is no power. Please know the power here is 1. Okay? If they didn't put 2, 3, 4, 5, 6, they just put that as 5t. Just know the power there is what? 1. So in this case, it will be what? 5 times what? 5 times what? 1. Good. 5 times 1, then t raised to power what? The power which is 1 originally. Then minus what? What were you minusing? Minus 1. Are you seeing that? Good. Then plus, now if you check, this one is never carrying a letter at all. It's not carrying t, is it not? So just know that this guy is called a constant because there's no letter attached to it. If it was 8 without any letter, it's called a constant. So how do you differentiate constant? Guys, the differentiation of a constant will give you 0. That's mathematical rule. Whenever you differentiate a constant, the answer is 0. So what is the differentiation of 8? The answer is what? 0. Differentiation of 20, the answer is what? 0. So this is what we now have. From here we continue. A is now equals to, guys, 3 times 3. The answer is what? 9. Then t raised to power, what will now be the new power? The new power, watch. 3 minus 1 is what? Raised to power 2. Good. Then watch out. 2 times 2 is what? 4. T raised to power 2 minus 1, what will be the new power? 1. Now I told you guys, if I put it and I did not put it, it's T1 that is there. Is it not? That what we observe is T1. So I choose to remove it. Plus, then 5 times 1 is 5. Now watch out. 1 minus 1 is what? 0. So it's now T raised to power what? 0. Whenever a number or a letter is raised to the power of 0, it is equivalent to 1. Is that clear? So this is 5 times 1 times 1. I hope that is clear. You see that, right? Normally we say 5 times 1 is 5. times what? Because t will now be raised to power 0. T raised to power 0 will change to what? Times 1. Are you seeing that? Good. Then plus 0. Let me just be adding that one so that you'll be observing the process. So we now have 9t raised to power 2 plus 4t plus what? 5. Then this one will now finally disappear. So this is now the function for the what? Acceleration I was talking about. We differentiated this for velocity. We now have this for acceleration. I hope you get that. Now we will not stop here because they say find the value. Find the instantaneous acceleration. We asked to find a value, not just the expression for the acceleration. So because they gave us a value for time, we just simply impute the 2 we have for time into this place, into here. We now have a final answer for acceleration. So let's do that together. Come, let's do it together. We now have equals to 9 in bracket. What is the value of time they gave us? They said 2. So raised to power what? 2. Are you seeing that? Plus 4 in bracket. What's value for time they gave us? 2 plus what? 5. From here, this is what we have. Guys, watch together. Let's do this together. 9 times. Now, mind you, this bracket is what? Surrounding just 2. So I will need to square what is inside this bracket before I will open it out. Guys, what is the square of 2? What is the square of 2? Is what? 4. Is it not? Plus 4 times 2. Okay, let me just write it here like this. Plus what? 5. So let's do this together. 9 times this is what? 36. 9 times 4 is what? 36. 4 times 2, 8. Plus what? 5. So this is now simple addition to get our what? Our acceleration. So when you add 36 to 8, you have 44. When you now add 44 to 5, you now have what? 49. And we all know that the unit for acceleration in any formula or any place it occurs is always what? m/2/second square. That is meter per second square. Okay? Or you can write it ms raised to power -2. But this is what the value and this is what answer. So guys, I hope you understand how I got this. So without wasting time, guys, let's quickly go to the question 2. Let's solve it together. Solution. We don't have time to waste. Let's go, let's go. Now watch out. They said in this question, they said a car starting from rest. A car starting from rest. Good. Now remember when we say starting from rest, if it was to be uniformly accelerated motion, we said that what? We'll use minus. But check, they said 30 seconds of motion. So that is not equation of uniformly accelerated motion. This is what? Nth time motion. Because they said in the 30 seconds. Is it not? So let's watch. With moving with a uniform acceleration of what? 4 meter per second. So the acceleration here is what? 4 meter per second squared. Are you seeing that? Good. They now said good. What did they say? Calculate the distance. In this case, x is what? Unknown. Covered in the what? 30 seconds. So the Tn is what? T. I hope you are seeing that. Okay? The Tn is what? T. So can we solve this with just this? Can we find our x, which is the distance? The answer is what? Yes. What is the formula we use since it's an nth term motion? We say xn equals to what? 1 over 2a in bracket Tn, which is what we have, squared minus t subscript n minus 1. That is the number before what? 3, which is what? 2. We replace this with 2. Also what? Squared. Are you seeing that? So from here we now have equals to 1 over 2 times what is our acceleration? 4, just the values only. Times in bracket, what is Tn? Replace it with what? T. Then square it minus what is the number before T? The answer is what? 2. Then we also what? Square it. Are you seeing that? So this is how it works. We have to simplify further. Watch out. Watch out. Let's say 1 over 2 times 4 times 3 raised to power 2. The square of 3 is what? 9 minus the square of 2 is what? 4. So this is what we have. We are still working on it, guys. Watch out. We will have equals to 1 over 2 times 4 times. We have to work out what is inside this bracket before we can open the bracket. So 9 minus 4 is what? 5. So this is what we now have. From here we can now say 2 here 1, 2 here 2. So call me the guys that are remaining. You have 1 times 2 times 5, is it not? So let's work that out. 1 times 2, 2. 2 times 5 is what? 10. Because it's distance, we will now say S3, which is what they asked us for, is equal to what? 10 meters. So guys, this is how it is solved. Now this will bring us to the end of what? Our revision, or our quick revision on equations of uniformly accelerated motion. But like always, before I call the class to a close, I want to give you guys a question to work out on. On this same topic, you have to work it out, pick out what I was giving, and pick the right formula to solve it. So let's have the questions now. Alright, this is the questions I want us to solve. It simply reads, a body moving with uniform acceleration. That's why all of them are under what? Equations of uniformly accelerated motion. Now, it has 2 points, 5, 15, first point, and what is the second point? 20, 60. On the VT graph, the velocity time graph of its motion, you are simply asked to what? Calculate the acceleration. Now, if you observe this very closely, you notice that what this is under rectilinear motion, because check, we're given 2 coordinates, or we say 2 points. Okay? Now, I will help you guys to interpret it so that you can further solve it. Okay? Mind you, is a revision. These are revision classes, so I have to make sure my videos are short as short as possible. So this is what you do. The first point is 5, what? 15. Now, mind you, which one will be for the velocity and which one will be for the time? This is how you know. Now, to know the one that will be for the velocity and the time, always remember TV for television, is it not? So the first one is T, the second one is V. Now, because this is the first point or the initial point, each of them will carry 1, 1. For the second point, they say 20, 60. Now, the same rule, TV. Now, because this is the second point or the final point, each of them will carry 2, 2. So now, can you now tell me what is V1? 15, T1, 5, V2, 60, is it not? T2, 20. So can you now find the acceleration? The answer is what? Yes. Using the formula for what? Rectilinear motion. So do it to solve this and let me know what you think the answer is in the comment section. Thanks for watching. Don't forget to share my video with your friends, classmates, and neighbors so that also can also get to know our question on this topic in physics. Equation of uniformly accelerated motion is being solved. Thanks for watching. I remain Pdex. See you in the next video.